A more common approach today is the modular approach, as with the Linux operating system. This kind of operating system has a number of basic services and APIs already part of it, but more importantly, as the name suggests, everything can be added as a module. With this approach, you can easily customize which particular file system or scheduler the operating system uses. This is possible because the operating system specifies certain interfaces that any module must implement in order to be part of the operating system. And then dynamically, depending on the workload, we can install a module that implements this interface in a way that makes sense for this workload. Like if these are database applications, we may run the file system that's optimized for random file access. And if these are some other types of computations, we may run the file system that's optimized for sequential access. And most importantly, we can dynamically install new modules in the operating system. The benefits of this approach is that it's easier to maintain and upgrade. It also has a smaller code base, and it's less resource intensive, which means that it will leave more resources, more memory for the applications. And this can lead to better performance as well. The downside of this approach is that although modularity may be good for maintainability, the level of interaction that it requires, because we have to go through this interface specification before we actually go into the implementation of a particular service, this can reduce some opportunities for optimizations. Ultimately, this can have some impact on performance, though typically not very significant. Maintenance, however, can still be an issue given that these modules may come from completely disparate code bases and can be a source of bugs. But overall, this approach delivers significant improvements over the monolithic approach, and it's the one that's more commonly used today.